Assalamualaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIVS Home School. I am Sabreena, Haque, assistant teacher of science, National English Version School, Haque. Dear students, today I am going to take a chemistry class on the based on chapter 7 for class 9 students. Dear students, let us move forward to today's topic. The name of the chapter is chemical reaction, and today we will start from oxidation number. Dear students, the oxidation number is the number of charge in atom or ion along with its sign. Then an atom or in molecules or radicals sometimes tend to donate electrons and sometimes tend to accept electrons. And the tendency to donate electrons of an atom is donated by a number added with plus marks, and tendency to accept electron of an atom is donated by a number added with minus marks, and in any molecular radical this number will plus or minus mark the oxidation number. And oxidation number is neutral, like sodium, magnesium, iron, etc. are taken by 0. Similarly, the atom in molecules that consist of homogeneous atoms like hydrogen gas, oxygen gas, nitrogen gas, chlorine gas, bromine gas, etc. are regarded to have oxidation number is 0. That means which molecules stray freely in environment, their oxidation number is 0. The oxidation number of iron in ferrous sulfate is +2, while the oxidation number of same atom of ferrous metal is 0. That means when it is only Fe or iron metal, that time its oxidation number will be 0. But when the iron make a compound with sulfate, that time its oxidation number is +2. That means the oxidation number can be changed. Now come to the how we can determine the oxidation number. This procedure is very important for you. In a compound, oxidation number of an element depends on oxidation number of other elements of compounds. To determine the oxidation number of elements is in a compound, standard oxidation number of elements used. Now come to the rules. These rules, total rules you have to learn. The first one, oxidation number of metal is positive and oxidation number of non-metal is negative. And you have to remember all the time this one. Look, this is the sodium chloride, and here sodium is metal and chlorine is non-metal. And sodium oxidation number +1 because it can donate 1 electron, and chlorine's oxidation number is -1 because which electrons donated by the sodium is taken by the chlorine. That's why its 1 electron increase than the proton number, its oxidation number become -1. Now come to oxidation number of neutral or free element is 0, like ferrous, sodium, magnesium, hydrogen gas, nitrogen gas, iron gas, chlorine gas, that's all are 0. Which elements are neutral or are free elements or molecules, that oxidation number is 0. Now come to the next one. Total oxidation number of atom of a neutral compound is 0. Like water's oxidation number, we know the hydrogen oxidation number is usually +1 because there is 2 hydrogen, so it will be +1 multiplied by 2, it will be +2, and oxygen's oxidation number usually -2, so +2 -2 will be 0. In your book the information is incomplete here. Now come to next one. Total oxidation number of atom of a charged ion is equal to their charge. Now come to sulfate radicals. Its oxidation number is -2, and the ammonium radicals is +1. There will be a plus sign. Now come to the next one. Oxidation of number of alkali metal, that means group 1's all the metals oxidation number is +1, like sodium, potassium, they can donate 1 electron, because in the last orbit they have only 1 electron. That's why they can donate 1 electron, and that's why their oxidation number is +1. Now come to next one, oxidation number of alkaline earth metal. That means the metal which is in the group 2 that has the 2 electron in their outermost orbit, and that's why they can donate 2 electron, and that's why their oxidation number is +2. Like the calcium, magnesium's oxidation number is +2. because they are alkaline earth metal. Now come to oxidation number of halogen in the metal halide is -1. You have to remember halogen have in the last orbit 7 electron, it can take 1 electron, and that's why its oxidation number is -1 because it can accept 1 electron, that's why its oxidation number is -1. Now come to next one. Most compounds oxidation number of hydrogen is +1, but oxidation number of hydrogen in metal hydride like sodium ammonia, in ammonia if we observe it is +3 always, and it is it will be -3, it will be +3. In ammonia the hydrogen oxidation number is +3, and lithium aluminum hydride, in lithium aluminum hydride there is the oxidation number of hydrogen is -1 because it is the metal hydride. In the metal hydride there will the oxidation number of hydrogen will be -1, like it will be +1, it will be +3, then +1 plus +3 it will be 4, and there will be -4, there will be -4 here. The oxidation number of hydrogen is -4. Now come to next one. In the most compound oxides oxidation number of oxygen is -2. In oxidation number of oxygen peroxide is -1, and in superoxide it will be half. Look here, we know potassium oxidation number is +2, so oxygen 1 is -2, this -2. Now come to the peroxide, potassium peroxide. Here -2 +2 -2, but here is 2 oxygen atoms, so if we divide by this 2 -2 with 2, then we will get -1. So in peroxide the oxidation number of oxygen is -1. Now come to in superoxide. In this is the sodium superoxide, and in superoxide here +1, here will be -1. So that total will be, here is 2, so -1 divided by 2, it is half, -half. So in superoxide the oxidation number of oxygen is half. You have to remember that. In oxide the oxidation number of oxygen is -2. Not only in oxide, most of the cases the oxidation number of oxygen is -2, but in peroxide the oxidation number of oxygen is -1, and in superoxide the oxidation number of oxygen is half. And this total rules also again written here, and in your book there is given some task that we have to find out the oxidation number of middle elements of the compounds. That compounds, if there is 3 elements, and we have to find out the middle one's oxidation number. So come to first one, potassium permanganate. For finding this, we have to must know the first and last element's oxidation number. We know the potassium oxidation number is +1 and oxygen oxidation number is usually -2. There is 4, so -2 multiplied by 4, so 8. So we can write -8, and we know the total oxidation number will have to be 0 of an compound. So here will be +7. So manganese oxidation number is +7. Now come to next one, that is potassium dry chromate. Again potassium one is +1, so +1 if we multiply with 2 it will be +2, and oxygen oxidation number is -2, -2 multiplied with 7 it will be -14. So make it 0, we have to write here +12, so chromium's oxidation number is +12. Now come to next one. Sodium thiosulfate, and here we know sodium's oxidation number is -1, there is 2 atoms, so it will be +2, and it is the -2 of oxidation number of oxygen, and there is 3 atoms, so 2 into 3 -6, so here will be +4, but there is here the chromium's oxidation number is 6 because there is 2 atom of chromium and there is 2 sulfur atoms, so the oxidation number will be +2. Here the sulfur's oxidation number is +2. Now come to the nitric acid. It will be +1, it will be -6, and it will be +5. So here the nitrogen's oxidation number is +5. Now come to sulfuric acid. It will be +2, it will be -8, so it will be +6. So here sulfur's oxidation number is +6. Now carbon monoxide, it will be -2, it will be +2. In carbon dioxide, it will be -4, -2 into 2 -4, so +4. Look here carbon oxidation number is +4, but here carbon oxidation number is +2. Now come to the methane, CS4, and it will be +4, it will be -4. Look student, here the hydrogen oxidation number is negative. Now come to phosphine, PA3, that will be -3, it will be +3. Here also oxidation number of hydrogen is negative. Now come to phosphoric acid, H3PO4, it will be +3 because there is 3 atoms, so it will be -8, 2 into 4 it 8, then here will be +5. So oxidation number is +5. Again lithium aluminum hydride, we already find out this in the chart. In lithium we know it is +1, here will be because it is metal hydride, that's why here will be minus 4, so aluminum will be plus 3. The middle elements oxidation number is here plus 3, and look here the oxidation number of hydrogen is minus 1. Now students, come to the next lesson. The oxidation number and valency are not same. This is an important question for your exam. Oxidation, their answer is given here. The total para is the answer, and the first line is the important for question. The oxidation number is the number of charge in atom or ion along with its sign. It may be positive or negative, integer or fraction. Like oxygen's oxidation number in superoxide is -half, and that means it is a fraction, and when it is in full number, that is in integer, the oxidation number of an element may be vary in different compounds. On the other hand, valency is the capacity of an element to bond with other elements. So it is always an integer and never positive or negative only. In this case, the inert gas valency is 0. Only inert gas valency is 0, because inert gas do not bond with any element usually. And this portion you have to learn. Now come to next one. This is another important question from it is a common question in SSC, that is oxidation, and you have to prove that oxidation and reduction is a simultaneous process. And you already know that oxidation and reduction and what is oxidant and what is reductant. Then oxidation reduction take place simultaneously. Let us consider reaction below. Now come, sodium react with half mole of chlorine and produce sodium chloride, and this product is sodium chloride. Here the reduction agent is sodium, because sodium donate the electron and chlorine take that electron, and that's why it is known as reduction agent. And sodium has donates one electron from its outermost shell to complete the oxidation half reaction. Dear students, we already learned about this. The oxidation is not a full reaction. We can't say oxidation reaction, because this is a half portion of reaction. So always we have to remember that oxidation is a half reaction, another half is reduction reaction. Then the oxidant is chlorine and accept the electron and completed the reduction half reaction. Oxidation half reaction is sodium. In previous phase it was the oxidation number will be 0, but when it donate the electron, its oxidation number become positive +1. And reduction half reaction chlorine, it was 0, but it has taken the electron from the sodium and it becomes chlorine, negative sign, or or its oxidation number become -1. If we add those two half of reaction, we get oxidation reduction reaction, that sodium 0 chlorine 0 become sodium plus chlorine minus, or sodium cation chlorine anion, and become the sodium chloride compound. And it is clear that the reduction agent has donated the electron to the oxidation agent. If the oxidation agent chlorine would not accept the electron, the reduction agent sodium would not have been able to donate electron, and so it can be said oxidation and reduction will occur together, and they are simultaneous process. Dear students, from here to here, the answer of oxidation reduction is a simultaneous process. You can write from here to here from your book, and this portion you have to learn. Now, since reductant donates electrons from oxidant accept the electrons, therefore oxidation reduction is actually the transfer of electrons, and there are some reaction where oxidation reduction occurs. They are addition reaction, decomposition reaction, substitution reaction or displacement reaction, and combustion reaction. Now come to the addition reaction. First line is the definition of addition reaction. A reaction in which a new compound is formed by combination of two or more elements or molecules is called addition reaction. There, if you observe, ferrous chloride added with chlorine and form ferric chloride. Dear students, here the oxidation number of iron is +2, chlorine is -1, and here 0, but here oxidation number of iron is +3 and chlorine is -3, that means 1. And another thing you have to remember, where the oxidation number increase, there the oxidation occurs. That means in iron this is oxidation, and here chlorine's 1 is 0, but here become -1, that means here reduction occurs. Here reduction occurs and here oxidation occurs. That means the oxidation number increasing is oxidation, oxidation number decreasing is reduction. That you have to remember. Another one, that nitrogen and hydrogen react with each other, produce ammonia, and when the addition reaction where two or more elements combine together to form a new compound is called synthesis. That means in the addition reaction where in the reactant are both are elements, that reaction is known also synthesis reaction. Now come to the decomposition reaction. The process in which a compound breaks into one or more element or molecules is known as decomposition reaction. Just opposite of addition reaction. Addition reaction, two or more things join and make a new thing, and in decomposition one thing break down into two things. Then phosphorus pentachloride, it break down into phosphorus trichloride and chlorine gas. Again here if you observe, here -5 it will be +5, and here -3 it will be +3, and here 0. So phosphorus oxidation number decrease, so here reduction occurs, and here chlorine was -5, it becomes 0. 0 is greater than -5, so oxidation occurs here. Again I am saying the oxidation number when increase, the oxidation occurs there, and when oxidation number decrease, the reduction occurs there. And if we electrolyze of water, we get hydrogen and oxygen. This also a decomposition reaction. Now come to substitution or displacement reaction. The process in which an elements or radicals displace another elements or radicals from a compound and takes its place is called substitution reaction. Look, this is you also get this example in your class 8's book. Zinc, when zinc react with sulfuric acid, it produces zinc sulfate and hydrogen. Again come why it is oxidation reduction reaction. Here zinc's oxidation number 0, it will be +2, it will be -2, and here it will be +2, it will be -2, and here 0. Look, zinc's oxidation number was 0, but it become +2, so here oxidation occurs, and here hydrogen was +2, but it becomes 0, so here reduction occurs. Now come to combustion reaction. The definition of combustion reaction is the process in which any compound or elements is burnt in presence of atmospheric oxygen and convert to oxides of its elements of its elements is called the combustion reaction, and usually heat evolves in the combustion reaction. This process also involves electron exchange, and for example natural gas or methane react with oxygen, air, produce carbon dioxide and water. Look, this is the natural gas and this is the burner of the gas oven. Through this methane it burned with the help of the atmospheric oxygen, and it produced carbon dioxide, water vapor, and also a huge amount of heat. With the by using this heat we usually cook our food. So this is a important reaction from where we get a huge amount of heat. And similarly sulfur, carbon, magnesium, hydrogen produce their oxides by heat evolves when they are burned. Sulfur plus oxygen, it is sulfur dioxide plus heat. Look, carbon plus oxygen, carbon dioxide plus heat, magnesium plus oxygen, magnesium oxide plus heat, hydrogen plus oxygen, here water vapor plus heat. These all are combustion reaction, but if you observe so carefully, it's also addition reaction, and not only addition reaction, because both are element, the reactant both are element, they are also synthesis reaction. This is very important for your MCQ. That's why I am giving this information. That means these all are here. The examples, these all are the combustion reaction, addition reaction, and also synthesis reaction. Now come to the non-redox. There are some reactions where the electron exchange does not occur. These reactions are called non-redox reaction, and this is the definition of non-redox. Neutralization reaction and precipitation reaction etc. are non-redox type of reaction. Now come to the neutralization reaction. An acid and a base react with each other and neutralize into salt and water in some reaction which are known as neutralization reaction, like hydrochloric acid and sodium hydroxide react with each other, produce the sodium chloride and water, and so they are both are this is the acid and this is the base, but these are salt and water. That's why they are known as neutralization reaction. Heat energy evolved from neutralization reaction, and that is to say neutralization reaction is exothermic. That you have to remember always, the neutralization reaction will be exothermic, and the value of del is negative minus 57.34 kilojoule. And another thing is, this kind of reaction, acid provides hydrogen ion while base provide hydroxide ion and hydroxide radicals, and these two ions react and produce water. In the sodium chloride solution, sodium ion and chlorine ion do not take place in the reaction. That means they just change their position, but this is the main reaction. That means from the acid the hydrogen ion came, and from the base the hydroxyl ion radicals came, and it produced the water. With the water 57.34 kilojoule energy is produced. That means from all the acid we will get the same number of energy. Finally, neutralization reaction is the water producing reaction, a mean of hydrogen ion and chlorine ions, hydroxide ions. Whatever the strong of both acid, the base is take in this place reaction, and they will provide the same ion and produce water. The amount of heat evolves to produce 1 mole of water is called the neutralization heat. This is the definition of neutralization heat, and calculation tells that always it evolves the 57.34 kilojoule heat. Now come to next one, that is precipitation reaction. When two soluble compounds are mixed in a certain solvent if any new compound is produced that is insoluble or is partially soluble in that solvent, that compound settle at the bottom of the container as solid. This solid new compound at the bottom is called the precipitate. That is the definition of precipitate. And the reaction in which the produced compounds settle at the bottom of the container as precipitate is called the precipitation reaction. Now, for example, there is silver nitrate when react with sodium chloride when react with silver nitrate, it produces the silver chloride and sodium nitrate, but sodium nitrate is more soluble than the silver chloride. That means silver chloride is partially soluble in water. That's why it precipitates at the bottom of the container, and this is why this reaction is known as the precipitation reaction. Dear students, after the precipitate product, which product will be precipitate, after that we have to give an arrow which is faces to the bottom. And look, there is the ferrous sulfate react with sodium hydroxide, produce ferrous hydroxide and sodium sulfate. And here ferrous hydroxide is not more soluble than the sodium sulfate. That's why it will be precipitated in the bottom of the test tube, and that is why there is a arrow given which is faces to the bottom, like this way. Okay, dear students, we will discuss the next part in our next class. This is your homework number 6. You have to write down, and not only write, you have to learn also the rules of oxidation number in different compounds from your book, page number 149. Dear students, this chapter is very much important for you, so read the chapter again and again and learn all the important topic and practice to find out the oxidation number and chemical reaction. Thank you.